over here that shows, you can see there, a nice pie chart that reflects that the majority is the orange that says that they want an assessment on December the 3rd that will cover the work not covered as yet. Okay. Right. Now next thing I want to look at is civil works. I want to look at civil works and show what it is that we would be doing next. This, of course, is uploaded onto MS Teams. I'm going to look at civil works, and I look at civil bulk earthworks. Civil engineering quantities, bulk excavations. Now you might say, well, so we've done bulk excavations. And now there's a slight difference between the bulk excavations that we do in building as opposed to what we do in civil works. When we do bulk excavations in civil works, we're looking at the content that will be measuring the bulk excavation based on the civil engineering quantities, 1990, and it's a guide for determining and using quantities for civil engineering construction projects. When we go through those, and this is basically to demonstrate the ability to measure civil engineering quantities for the section bulk excavations, and it's to be able to understand and interpret civil engineering quantities. Now you'll notice the slight difference in what we have previously measured when dealing with bulk excavations. Bulk excavations in soft material, we're measuring that in soft material, and this item includes soft material and soft rock. And any material in hard rock material shall be measured separately as extra over and will be measured in meters cubed. Now here's the important thing. It's something that you guys would enjoy in that, because I know how risk of collapse always collapses our bridges. Is that risk of collapse to sides of excavations and keeping excavations free from water is deemed to be included in those descriptions. Carting away, surplus or otherwise, material that is there, it will be on or off site, shall be measured as follows. So the first 0.1 kilometer that it has to be carted will be free. For the next 500 meters is paid for and is measured as extra over for limited overall. Limited overall means the distance is not too far that we need to cart this material away. For any distance beyond limited overall is paid for and is measured as extra for long overall, and is made up of the volume of material multiplied by the distance it is hauled, and the unit of measurement for that would be meters cubed per kilometer. Just some rules there that we need to comply with when dealing with bulk excavations for civil engineering. You can see already there's difference here, and I mentioned this when we dealt with plumbing. I mentioned that there are ways in civil engineering that when we measure a manhole, we will include everything in the description and just measure that manhole as one, or however we will be measuring that. So when we're dealing with bulk excavation in civil, it is slightly different and how it is being measured. So we will now look at our first drawing. In my first drawing, I'm just going to override Okay. This drawing should look very familiar to you. I should have turned it, I should have rotated here. Rotated. And this drawing should look familiar because this drawing shows, you can see that over here we have a number of reference points, levels that we were given that were taken over, and we are now requested to measure the bulk excavation to this civil engineering drawing. And what we would be using for this drawing, for this bulk excavation here, we would be measuring this in Simpson's rule. And you all still understand the issue around Simpson's rule. You know that Simpson's rule says to us that for the volume it is the distance over 3, and the distance would be reflected as that 10,000 that is there. The distance over 3 multiplied by A1, which is my first area of my first section, plus AN, or area of my last section, which is A7 in this instance, and then 4 times a area of my even numbered sections, which would be 2, 4, and 6, and then 2 times the area of my other sections, which would be A3 and A5. And we are told that we need to generate the quantities for bulk excavations to a reduced level of 4720. 4720, and I see over here that I have 4720 over there. But I will now unshare and go through the quantities that we have for ourselves over here, and I would therefore share my screen. Can you see my screen? Okay, you can see my screen. Thank you. Thank you, Tabasa. You can see my screen. Right. If I look at the drawing that I've just shown up there, and I will revert back to that drawing now when I'll be writing on the drawing and indicating exactly what it is. But I need for us to just see here and to understand that we need to measure the bulk excavations to a reduced level of 4720, which is the lowest point on my site, right? And I would use Simpson's rule that tells me volume equals the distance divided by 3 multiplied by the area of my first section plus the area of my last section plus 4 times the area of my even sections and 2 times the area of my other sections or my uneven odd sections. So a bulk excavation is given to us in soft material, in open face, to reduced levels. See there, a very important note. No need to measure risk of collapse, because that is deemed to be included in my description. So for this drawing that I'll be measuring there, I will now understand and I will measure that all of this will be in meters cubed, and for my extra over for hauling, it would be my measurement for in meters cubed per kilometer. So without further ado, let us get into that and allow me to go back to the drawing so that I can now then share and make the notes on there that I need to in order for us to be measuring this overall. I suppose I should stop presenting whilst getting that. You guys are pleased to ask me the needed questions for this so that I can attempt to at best answer whatever the queries are that you might have for me. Okay, whilst I upload, share my screen. Start now. I'm going to, let's hit the drawing. Okay, so when we now look at Simpson's rule, we said that Simpson's rule says that the volume equals D, and D refers to the distance, that will be the distance between there, over 3, multiply area of my first section plus the area of my last section. Can I write there? Last plus 4 times.
Sir, we can't see your screen.
Are you not seeing my screen?
Yes.
Okay. I will start that over again.
Okay.
Let me. I'm supposed to be sharing. See my screen now?
Yes, sir.
Okay, great stuff. Right. Now I'm struggling to rotate this one. I could rotate it on my other computer, but I'm now battling to rotate it over here. But be that as it may, we will work through this. As I say that, we are now saying that we are measuring using generating the volume, and we are using Simpson's rule. Okay, and Simpson's rule said it's D over 3 multiplied by area of my first section plus the area of my last section plus 4 times the area of my even sections plus 2 times the area of my other sections. And that we know from the drawing here, we know that the distance for D is given to us as 10 kilometers or 10,000 meters. That is the distance from there to there. So if I have to work through this and I have to measure these dimensions here, I will look at that A7 would be my last, and A1 at the bottom here. A1 at the bottom would be my first. So it'll be, how do I calculate the area of each one of these? How do I calculate that? I calculate them by drawing a table for myself. And the best way to do this is the table that I'll be drawing is for all the levels that I have, over here. I'll be using those levels on A1. I'm using the levels of all of those on A1, and the same way in which we did the weighting, where we would determine the average or the weighted average between those points. We would therefore add 4, 720, 4, 720, add all of those, divide them by the number of levels that we have. If I count, I'll see it is 1, 2, 3, 4, 5, 6, 7, 8. And whatever the average is of those weights that I have there, I would then subtract 4, 7, 20, which is the level to which we were instructed or to which we were asked to reduce these levels to. And whatever that difference there is would be the weighted average from there to, would be the weighted average to there. That will be for A1. I'll do the same for, but the best way in which to do this would in all probability be to do it something like this. You can see my screen. In my screen, you can see here that I have now indicated at A1 all my different sections up to and including A7, where I have added each and every level that I have, each and every weight that I have. I've divided that by 8, which is the number that I've shown to you on the drawing. I've arrived at an average weight there, and I'll then deduct or subtract my reduced level of 4720, which will then give me an average depth that I will then, for A1, would therefore be 165 millimeters. And for each one that we go through, we would then determine what each one of those would be all the way up to A7. So when I now measure this, when I now do my description in my description column, I'll then go and I say bulk excavations in soft material in open face to reduce levels, and extra over excavations for limited overall. Nice, just for limited overall. But we are told, and it's now not written in there, that we need to ensure that this gets hauled 9 kilometers away. An extra over excavation for long overall, see that times 9 kilometers, and that will give us the volume per kilometer would then be added in that section over there. We also say extra over bulk excavation for carting away surplus material to a dumping site selected by the contractor. And that is it. That would be the descriptions that we would have for this particular exercise or drawing. But now it comes down to how we will ensure that we incorporate the formula into this section over here. And what I would do is just bring up so that we can see how all of these are being incorporated, to show how all of these are not just incorporated, but how we will ensure that the dimensions are being included in what it is that we have over here. To ensure that what it is and how best we would ensure that formula D over 3 multiplied by A1 plus AN plus 4 times AE plus 2 times AO is incorporated into my dimension column. And in doing so, I will then have to do the following. As you can see, my formula is given to me over there. And I will start, I know that I have seven of these sections. So for my first one, I'll start out which says D over 3, and D equals, in this instance, we said D equals 10,000 meters. And I'll go in and I'll say 70 meters. Now, where do I get 70 meters from? Where do I get my 70 meters from that I claim over here? If I have a look at my drawing, anybody want to say something?
As I was saying, it's a vertical axis between the sections going up. It's 10, between the levels.
Okay, I will just increase the size. Okay, and I will just bump over and go into this here. You should be able to see my drawing. Notice that the number of, because my area runs from where the 4900 is all the way down to 4720. And if this is 10, then I can assume that this, unless otherwise stated, that there's 1, 2, 3, 4, 5, 6, 7, which gives me 70 meters from the 4900 all the way down to 4720. Are you all with me there, with what I'm saying there? All with me, right? So that is where I'm now calculating the length of that area for that, where you can see my mouse scrolling up from 4900 to 4720. Okay, so that is my 10 as I swap over to my dimensions again as I upload. Not sure if you can see my screen. Not yet. Why can I see my screen? Okay. Upload. You can see my screen now? Okay. So we said that on A1, and I've shown you where A1 is. A1, the length is 70 meters. We've determined that by going through that my average weight there, my average height, my apologies, not weight, my average height is 165 millimeters. And 165 millimeters, obviously when written, converted to meters, it will show, and converted to 2 decimal points will show 0.17. And I've add all of these, get my total, divided by 8, and subtract the reduced level from that total, which will then give me my average depth. And in that, I would then see that I have my 70 meters. I need to now just illustrate everything that the formula gives us. Not that it should be necessary. Okay? My D is 10. That's my 10. Divided by 3, that is times a third. I've indicated my 70 meters we have shown you on the length, and my 0.17 is the average depth on that first one. So that's my first one. On A7, which is my last one, or I can go through it and do it for each section as we go along, whereby I can now also show to you that I will do my evens. So these will be my evens. And these would be my others. So that is my last, and that is my first. So I've not done this one. And I can either go through doing it A2, A3, A4, or I can do all my evens together, or all my odd numbers in my last one together. But all of these would be added together. They all would be added. There's no multiplication of. But this one would be times 4, times 4, and times 4. And those two would be times 2, and those are just one time. Right. So we're looking at my A2. I will still be adding. A2 would be my distance of 70. I've determined that my average depth is 300, and that my D is now 10, multiplied by 4, multiplied by a third. For 3, it will be multiplied by 2, multiplied by a third, with a different average height that is given to us and is illustrated as is shown there. Each one is 7. But that one is now times 2, because that is an odd, that is an even, and I have another even, which is times 70. And we then go through the entire list until we arrive at the volume that will have to be carted away to ensure that we now find ourselves on that level of 4,720. That's the volume that needs to be carted away. And for the long haul, we will multiply that by that, and whatever comes in there will be meters cubed per kilometer, the extra over for the long haul overall. And over here, we can see that the formula shows us that A is my area in meters squared. In my formula, it says A meter, D is the distance between the sections, L1 is the length of the section, the length of the last section, length of the even numbered, and length of the odd numbered sections. Nothing difficult about that. Are there questions that you guys would like to ask me before I move on to the next section? Nothing. Great stuff. Great. That's totally awesome. Right. When I now go in and I look at my second drawing, my second drawing now shows me the grid line to a sports field, whereby we now need to ensure that that this sports field is leveled out. You can see in some sections it shows cut, in others it shows full. And we now need to ensure that we arrive at the reduced level of 107.5. It is the reduced level that we need to get to. So when we go and we measure that, we look at this drawing, this particular drawing, says that the note says that a new level of 107.5 imported material 10 kilometers from site. You need to cart away surplus material 15 kilometers from site. And the method that we need to use to arrive at these is Simpson's rule, using the same formula that we've just used previously. So from this we can see that is an area that shows that has to be cut. This area that will have to be filled up in order for us to arrive at the reduced level, the required reduced level. When we go through and we have a look at this, I will again just jump between the screens. Okay. For my bulk excavations, and this now refers to RC 002, which is my bulk excavation for my sports field. And again, I'll start out by excavating in soft material to reduce levels in open face. One thing you need to understand, you've not heard me use any categories here as yet. And extra over for limited overall, and an extra over for long overall, and then we give the distance of the long overall where we will have to take this to. And the previous one, you noticed that we had a table that shows it spells it out much easier in order for us to ascertain the average depth of each one of these excavations. But from what we see here, and from what we can gather, having had a look at the drawing, is that where some areas will have to have full, some areas will be cut. But what are we interested in? What are we interested in? When I take you back to the drawing, I just take you back to the drawing again, to show to you that you can see, maybe I can blow that up some more. Okay. If you have a look at that, it shows 109.5, 108.9, 108.2, 107.5, 106.3. And we notice that our reduced level is shown to us there as 107.5. When I look at 107.5 as my reduced level, I notice that that line there, I cannot paint it on this drawing here. I'll try to do that. But that 107.5 is the reduced level that I will have to work towards. Meaning that where this level is lower than that, I will have to bring full in over here to ensure that we arrive at that level of 107.5. And these would be cut down to that. Right? So now when we have a look at what we have here, and I need to now also determine what my distances are between my respective sections. I need to determine what those distances are, because when I look at my drawing, See that it shows to me is 120 meters, and divided by 6 will be 20, 20, 20, 20, 20, 20. Each one of that, those will be 20. The distance there would be 20 meters, and when looking at the opposite direction, my length there is given to me as 80 meters, but that is not right. That's not right. Let me just get my... Okay, I'll reduce the size of that. If you have a look over here, it says imported material will be from 10 kilometers from site, and carting away surplus material will be 15 kilometers from site overall. And I need to work excavations, not concrete structures. My apologies. We are working towards the not for the sport fields, but for the school building. It's not the sport fields. My apologies, guys, but it's for the school building. Right. And for the school building, it is from this point of 103.7 to 105.3, and my reduced level is given to me as 102.5. So from this section over here, I know that all of this would be in line with what it is that we have to do. And in dealing with that, there will be no filling of the section where the school building would be situated. This here is not 5 meters, that is 50 meters. That is a mistake. That should be 50 meters over there, and it's 90 meters across. And 90 meters across would then give me 1, 2, 3, 4, 5, 6. 6 of them. And what would my D be if I have 6 of them at 90 meters? My D would be 15 meters. Is that correct? Because 90 divided 6 give me 15 meters. So the distance between each of my grid levels would be 15 meters over there. So I will then go through, and at A1, I will add the 105.3, I'll add the 104.2, the 104.7, and I'll add the 103.7. That gives me 417. 417.9, I divide 4, and it gives me a total of 104.48. And when I deduct my reduced level of 102.5 from that, I get 1.98 meters. So I will just need to swap these drawings around. Do that. So drawings around. Okay, you can see my drawing there, and on my drawing, So I've now looked at and I'm working with the levels saying that the 90 divided by 6, that gives me a D of 15 meters, and that should be 50 meters, not 5 meters. So I'll be adding 1, 2, 3, 4. Adding those over there, and in adding those and dividing there, I get my average here of 1.98 meters, an average depth of 1.98 meters. So when I now eventually go and I say, and I use my formula of D over 3, which will be 15, and my length would be 50 meters, multiplied by my 1.98, multiply by 15, which is my D, and that multiply by a third. And that will be for A1. My first one. That will be 1, 2, 3, 4, 5, 6, 7. And for my seventh one, or my last one, it would be adding all of those together and then getting an average depth of 0.88, whereby we add those, divide by 4, subtract my reduced level of 102.5 from that gives me 0.88, which will then be 50 times 0.88 times 15, that will also be just times a third. My evens and my odds. Those will be multiplied by 4, and these will be multiplied by 2. Part of my description that I would also have included in there is that I would then add extra over for my limited overall, and then extra over for long overall, and the drawing shows me what my long overall should be. It shows me that will be carting away surplus material 15 kilometers from site, and that would then, my total would then be given to us in meters cubed per kilometer. So doing bulk excavation, there is nothing to that. It is a fairly straightforward exercise that one can go. The only difference is that we are now not using the same levels that we found to be used in my other sections. But when I also look at this drawing here, look at this drawing. There also is something else that I notice on this drawing. What is that we notice on this drawing? Anybody tell me what it is that they see on this drawing that is different to the other? Please,
I am going to say, looks like 6 or angle of repose. Not sure if like
angle of repose. You see the angle of repose? Angle of repose that gives us there. There I have a triangle. There I have a triangular pyramid that I have. So, I also need to calculate those over there that I've just identified and highlighted, because it'll also be, we'll also have to calculate for the excavation there. There I have two. I have two pyramids, which is square. I have a triangular pyramid, also times 2 for that side there. And of course, I have to do these two sections over here for what I have to calculate. And in order to determine the excavation for those over there, I will now have to determine and say 104.4 minus 102.5 gives me depth of 1.9 for that. On the opposite side, I have 105.3, 102.5, deducting that gives me 2.8. Right? Over here, also have a triangle there. So I have 103.7, 102.5. That gives me 1.2. So for those pyramids, instead of 2, I have 3 pyramids. Those pyramids would be 2.8, 2.8. My depth would also be 2.8 times a third, 1.2, 1.2, 1.2 times a third, and I will also have 1.9, 1.9, 1.9 times a third. Those are for the 3 pyramids, square pyramids in my corners. Still, bulk excavation to what I have to do there. And now I need to go and I need to look at the bulk excavation to my triangular sections. From there, I know that we have 1.2, and my length is 90 meters, so it will be 1.2, 90, multiplied by half times a third for that section there. For that section down there, it would be 1.9, 50 times half, because it's a triangle, times a third. Takes care of that section over there. But now what about these sections down there? How do I do those? There's of course one of 2 ways that I can go in and do it. What's the one that we were taught? The prismoidal formula where we can go in and say h over 6 multiplied by the large area plus the small area plus 4 times the middle area. Or of course we can go in and we can say, where my height is, we can say 2.8 plus 1.9. Say 2.8 plus 1.9. It gives me a 2.35. Or the best way for us to do that, for us to do the excavation for that section would be to use the formula of h over 6. Use that. So when dealing with that, I will then therefore say that my large area would be my 2.8 times 90 times half times 1 over 6. And I have 1.9 times 1.9 times 90 times half times 1 over 6. And I then have to determine and say 1.9 plus 2.8 divided by 2 gives me 2.35. It was 2.35. So 2.35 will therefore be my average, and I will then have my 2.35 times 90 times half times 4 over 6. That will be for that section there. And when I do have to do the section down here, it will again be 0.28. No, not 0.28. 2.8 by 50 by half by 1 over 6, 1.2, 50 by half by 1 over 6. And we would have to determine by saying 1.2 plus 2.8 over 2 gives me 2, and that will be 2 times 2 times 50 times half 4 over 6. For the volume to take care of the section as it is shown over there. And that will get us for everything that we need to do insofar as the bulk excavation for the civil bulk excavation, so civil quants for this drawing would be in order for us to generate those. Time for questions. Any questions? I don't see no hands. Everybody good? Mr. Madolo.
Hello, sir. Sir, so in terms of the description, since you said the risk of collapse is will be assumed that it's included in the standard system, and you have proposed that there anything that standard system would say about it in terms of the
I cannot hear you. You're breaking up there, Madolo.
So I was saying, in terms of the standard system, in reference to the angle of repose, would it have anything similar to what you were saying about the stock collapse, that it's going to be included there? Would now the angle of repose also be assumed that it's included in the description, or we need?
No. The angle of repose, we have just measured the angle of repose. We just measured the expression for the angle of repose. Are you with me?
Yes, sir. Thank you. Thank you, sir.
By virtue of us calculating all those three pyramids, because remember, if I cut through that, I see that, and that there is my angle of repose. I'm not cutting that. That would be what you see there.
Yes, understood, sir. So I just thought like
So,
maybe there's
if-
something.
I'll just say something else.
I thought maybe there is some maybe some rule that it says about the description, but I hear you, sir.
Now, if we did not have that, we would not be measuring risk of collapse there. That would be deemed to be included in my bark excavation description.
Understood, sir.
Okay? It'll be included in my bark excavation description. But because we have it like that, we will have to measure the angle of repose. So there still is no risk of collapse. There still is no risk of collapse. You got that now, Madolo?
Understood, sir. Understood, sir.
Okay, great stuff. So, as you can see, we're now not looking at the Bible that we are working from, that we normally use for the standard system of measuring builders' work, 7th edition. We now use a different animal that we have here, that we have to conform to, which makes life a little easier. Okay. If there aren't any questions, that's great. I'd like to move on to the next. I have uploaded for you some dimension, some information with regards to different shapes that we use in civil engineering, quants and measuring with them and so on. It deals with earthworks and just some of those aspects that you can go through. But I want to particularly get to this drawing. Interesting drawing. What does that look like?
Is this a reservoir or is it?
It is a reservoir. It's a reservoir that is placed, as you can see, it's a reservoir that is placed up in the air. You can see where your reduced level is down here. The reservoir sits up in the air. You can see it sits 4 meter 100 from reduced level. You can see the shape of it. It is circular in shape. And we are tasked to generate the quantities for this reservoir. We are tasked to generate the quantities for this reservoir, and our specifications that we are given is that we need to cart away our surplus material to a distance of 20 kilometers. We need to allow 20,000 for the steel reinforcement. In the blinding, we find that the concrete strength is 15 MPa. The basis, we find the concrete strength of 20 MPa. And 25 MPa in the columns, the walls, the beams, and the slabs. And all the formwork to this particular reservoir should be smooth formwork. We need to provide formwork to the sides of the bases. Working space, we need to excavate 300 millimeters back for working space. Information given to us, and if you go through the drawing, we notice that there is a blinding of 50 millimeter below the bases. The bases are given to us on size. The size of the bases are given to us as 1500 by 1500 column bases. The columns are given to us as 300 by 600 millimeter columns. We have a wall around my reservoir of 300 millimeters thick. See that the columns are shown 300 by 600. We see a beam of 250 by 300 millimeters. Beam that runs across the underside of my reservoir. At the top we see an opening of 800 by 800 opening, and the slab thickness of my reservoir is 250 millimeter thick. And the external diameter of the reservoir is given to us as 8 meter 100, as is illustrated over there. So we are now tasked that we need to measure. My reduced level is at 14.0 and the top of my base is at 14.25. My base thickness is 400, and we are tasked to generate the quantities for the concrete works for this reservoir. When we go in and we start measuring, we go out and we look, first and foremost, we look at the measuring list at what all we'd like to include here. To excavate for my bases, extra over for limited overall. You see, we're now measuring civil, and everything that we do, we measure for limited overall, for long overall. The long overall will indicate the distance of 20 kilometers as per the drawing here. We are measuring our concrete in our bases, concrete in our in our blinding, in our bases, the formwork to the sides of our bases, the excavating back in earth for working space. The 300 millimeters we need to indicate. We measure the concrete in our reinforced concrete columns, my beams, my slabs, in my walls, and then all of those need to get smooth formwork. Smooth formwork due to the horizontal surfaces of the beams, to the vertical surfaces of my beams, circular on plan, to radius, including propping up, smooth formwork to the horizontal surfaces of the beams, smooth formwork to the vertical surfaces of my walls, circular on plan, to radius, and smooth formwork to my soffit of my slab, including propping up, smooth formwork to the vertical sides of my walls, circular on plan, to radius, and smooth formwork to the soffit of the slab, including the propping up and removal of the formwork through the small opening, and smooth formwork in narrow widths, and then provisional sum for my reinforcement. So just a measuring list that we prepare, everything from the drawing that we have seen there, in order for us to clearly see exactly what it is that we need to be doing. When I start out, say that the following in a concrete reservoir on columns. Telling the contractor, civil engineering contractor, what he has to measure, and we tell him where this is, stands on columns, and excavating earth for basis provisional. That's 1500 by 1500 by 0.2. Is that correct? When my drawing tells me that my base is 400 thick, tells me my base is 400 thick, but when I look at my levels are given to me at 14.25. That is the top of my base. I have 14.00. That is reduced ground level. And the difference between those two is 250. The difference is 250. And when I say 400 minus 250, that gives me 150. So why, sir, do you have 200 over there when it shows 150? It is because I have 50 millimeters for my blinding. That gives me a thickness or a depth of 200 millimeters. Just to show what it is I'm talking about, I'll just upload this drawing here that you can see. If you can see my drawing, right over here, the 400 thickness of the base is given. The difference there between those two levels is the 250 I spoke of, which leaves me with 150 down there, and we have to add the 50 millimeter blinding, and that gives me my depth that we have to excavate of 200 millimeters deep. The remainder of that base will be sitting on top of, what will be above the ground. Or with me with how I arrived at the dimension of 210? Okay, so the 200 that I'm given is calculated. You can also see that down at the bottom here, where that calculation is also reflected as to where a 200 millimeters is derived from. Okay, so my excavating for earth in bases and then extra over excavation for limited overall, which is also provisional, and then extra over excavation for long overall times 20 kilometers, because that is what my description had told me that I need to, how far I need to cut my excavated material. Then I have my 15 MPa mass concrete in blinding, all provisional. This is 1.5 by 1.5 by 0.05, and we have 4 of those bases. Four of those bases, which we can clearly see on the drawing here. 1, 2, 3, 4. Right? So also need to measure my concrete in 20 MPa reinforced concrete in my basis. It's just that we find on top of our blinding, which is 1 meter 500 by 1 meter 500 by 0.4. Because the thickness of that base is given to us as 400 thick. We measure our formwork to those bases because it says that the bases need to have formwork to it, and it's smooth formwork. I repeat and I reiterate, smooth formwork. The size of bases, provisional, and my sizes are 6 meter by 0.4 by 4. Or, as you see it's shown here, 1.5 by 0.4 times 4 sides times 4 bases. So now we need to excavate back in earth for working space, including backfilling and compaction. That is 1.5 by 0.15 by 0.15. And 1.5 is a depth, and 0.3, the 0.3. Oh, but why is this working space measured in meters cubed now, sir? When we measured in other working space, it was measured in meters squared, where we indicated what the distance was from what the distance was between the excavated face and the structure face. And you remember that we used to do that, and we indicated that distance was 300 millimeters. But now we measure this, as we can see over here, we measure that in meters cubed because we do not indicate the 300 over there. No, we do not indicate that 300 there. That 300 goes and it forms part of my dimension that we have here in the working space. With me? So that space where the working space will go in will be measured in meters cubed. There's a distinct difference between dealing with builders' quantities and civil quantities. Right. So then we have our formula, our concrete in our concrete columns. The size of my columns are given to us as 300 by 600, and they go, when I look at the column heights, they are 4 meter 100, excuse me, 4 meter 100 from the top of the base to the underside of the beam. And that is 0.3 by 0.6 by 4.1, and we have 4 of those columns. concrete in our beams. Now our beam runs circular on plan. Circular on plan, but when measuring concrete, we do not indicate anything about circular on plan when measuring the concrete. It is only when we measure in the formwork where we now illustrate that, and I will go through and I'll do the 25 MPa reinforced concrete in my beams, where I need to determine the average circumference of my beams. And for my beams, I know that my external dimension is 8 meter 100. My wall thickness is 300. The wall thickness is 300. My beam size is given to us as 300. So I now need to indicate where this would go from, and deducting the 600, 300 and 300 on either side. So the length of my beam through the cross would be 6 meter 900. To show that, I think I need to really spend the time on this. You can see we have the 8 meter 100 there, which takes me from outside to outside. And I need to have, I know that this beam here is 300. So it's 300 plus another 300. So in order to determine what the length would be, from the inside, I would therefore have to now measure, take my 8 meter 100, deduct 2 times 600, because that's 600 across, 600 across, and my length in there would then be 6 meters 900. Times 0.3 times 0.25. That is for the beam running across there. I also need to now measure from there to there. But I need to deduct that 300 over there. So it will be the 6 meter 900 that I calculated minus the 300 gives me 6 meter 600 times 0.3 times 0.25. And then I now need to determine what that dimension would be all the way around there for the circular on plan, because over there I can see that there's a beam there that is circular on plan. That shows me my 600, my beam that runs 600 across. So I will have to now determine what my radius is going to be. Because 8 meter 100 divided by 2, that gives me a radius from there to the outside. And then I have to now arrive at the center of that 600, which is 300. So it gives me 7 meter 500 divided by 2 gives me a radius, and an average radius takes me to the center there of 3 meters 750. That 3 meters 750, I will then use as my radius, multiply that by 0.6, which is the width, and multiply by 0.25. And the 0.25 is the depth from there, where you can see my cursor, to there. Because the 600 minus the 350 slab takes me up there. So it will be 0.35 times 0.6 times 0.25 times pi times 2. Because the formula for the circumference of a circle, as we see in this instance, the circumference of that circle there would be 2 pi r. So we can calculate the volume from that. I will stop here, and I will continue tomorrow when we will further explore and go forth. I have a meeting at 12:30 that I need to jump into. Thank you so much for your time, guys, and I'll see you guys tomorrow morning 8:30, where we will club this concrete work in here. And please ask your mates to attend, because they are missing out on me. Go well, guys. Stay safe. and we will be in touch tomorrow. Cheers, guys. Thank you.